हेलो दोस्तों, वेलकम टू सनराइज क्लासेस। आज मैं आपके साथ एक बहुत ही इंटरेस्टिंग टॉपिक डिस्कस करने जा रहा हूं दैट इज वेरी इंपॉर्टेंट फॉर द बीपीएससी टीआरई आल्सो। द टॉपिक इज द sorting mechanism. We will discuss all the sorting mechanism that is available in your syllabus. We will see about the complexity, we will see about the stability of the process, and we will cover all the important MCQ related to this sorting mechanism. तो इस वीडियो में आगे बढ़ने से पहले आपसे एक अनुरोध है, अगर आप इस चैनल पर नए हैं तो प्लीज आप सब्सक्राइब कीजिए एंड शेयर विथ योर फ्रेंड्स। थैंक यू। बबल सॉर्ट, सिलेक्शन सॉर्ट and the insertion sort. This is in the 12th syllabus, but I have added the merge sort, heap sort and quick sort just for the references. So what is saying the bubble sort? The bubble sort, you see here, bubble sort, selection sort and insertion sort. All the three sorting mechanism having the worst case complexity is O(n) square. It means that there is loop inside the loop, and then they will compare the elements and they will keep the positions. The bubble sort is, you can see here one important thing, it's an exchange technique. What it means, that there is a, if the two elements are here 5 and 2 and sorry 5 2 and 7, the exchange means they will exchange the data like this. So this is called the exchange technique. And bubble sort and the quick sort, they are using the exchange technique, you see here. So remember this, only bubble sort and the quick sort is using the exchange technique, and the time complexity for the bubble sort is n square, worst case scenario. In the best case scenario, the time complexity for bubble sort is omega n. It means that if the array is already sorted, then it will take, the complexity will take at the time is the omega n. The worst, the space complexity is n. It means that whatever the array you have given to sort, that is enough to perform the sorting. We don't need any extra memory. Sorting stability, yeah, is stable, so positions of each element is fixed. If you run multiple time also, you will get the same result. The passes is here important. We understand that complexity is n square, means there is two loop, one is outer loop, one is inner loop. So passes here for the bubble sort, for the outer loop n, for the inner loop is n minus 1. The algorithm is internal algorithm, so we are running all the data in the RAM. We don't need to interact with the secondary memory. Let's talk about the selection sort. Selection sort, here average and worst case time complexity is n square. Even the best case also it's a n square. So always for the selection sort, the complexity will be n square. The space complexity is 1. It means that they don't need any extra memory to perform this selection sort. The sort stability is unstable. So see here, out of these three, bubble, selection and insert, only the selection sort is unstable. Even the complexity is n square for the best case. Passes is n minus 1. Remember this is n minus 1. All three are internal only. They are using array. The third one is the insertion sort. It's very important. Insertion sort. So here you see the best cases, the complexity is omega n. What is the best cases? The given data is already sorted. So we have to perform the sorting on the sorted data. It means that the complexity is only omega n. But in the average and the worst case scenario, the complexity will be n square. What is the worst case scenario? The data is sorted but in the descending order, reverse order. What is the space complexity? Space complexity is 1. It means that we don't need any extra space. it's a constant time. Yeah, this is stable. Here passes means number of iterations. So top loop, the outer loop will run only for n minus 1 time. Here also the outer loop will run only n minus 1 time. This is again the internal. Here important thing, in technique you see that this is using array, but here you see incremental. So here technique is incremental. What it means? It means that they will perform first operations, then second operations, and then third data, and similarly n data. So to complete the process, they will first perform n minus 1 data, and then they will do on the n data. So this is the step by step they are doing. I will give you one scenario for selection sort. Sorry, for insertion sort, it's like sorting the card. So for example, if you have a card in your hand, how we are sorting this? We are sorting in the case we are looking into the card, and if you find that the, for example, fourth card is not the right places, then you will pick it and you will keep at the right places. So this is called the insertion sort. So the arranging the card, playing cards, is the example of insertion sort. Now let's talk about, quickly we will talk about the merge, heap and quick sort. So what is the merge sort? Merge sort is using the divide and conquer algorithm. So you can see here divide and conquer algorithm. So what it will do, it will be very useful for the huge data. Generally the linked list they are using. They are using the linked list, and what is doing, they will first divide the data and they will sort it and then they will merge it. So that is called the merge sort. The divide, they will divide from the middle. This is the important. They will divide from the middle. If it's the even number or the odd number, then like both the if after divide both will be not the same when having the one element more. So merge. Okay, so next is, let's talk about the merge sort. Merge sort is like, we have a use data, it will be useful for use data, and the use data then they will divide into the small data, and then they will compare it, they will sort it, and then they will merge it. So that is called the merge sort. So we understand that they are using the divide and conquer algorithm, divide and conquer technique, and this is using internally, like it will be very useful for the linked list data. So what is the complexity? So here time complexity is n log n. So for the merge sort, the time complexity is n log n, and a space complexity. You see here, this is the only algorithm where we have a space complexity. Why? Because performing the merge sort, we need an extra array. Actually, we need extra 2 array to perform the result. So that's why here space complexity is n. Now, is it stable? Yes, it is stable. How many passes is required? So only log n iteration is required. Is this algorithm is external? Yes, this is external. Why? Because we have to keep some data on the secondary memory, because this is useful for the huge data, especially we are using in the database merge sort. Next one is the heap sort. What is the heap sort? It is using the binary tree. So you see in the technique here, it is written binary heap data. So we know that there is a mean heap and max heap. So using that, they are sorting the data. Here also the time complexity is n log n. So time complexity for merge sort and the heap sort is same, n log n. Space complexity, you see that it's a constant. So this is good in the space complexity. This is also stable and internal. So no need to use the external data or secondary data. The next one is the quick sort. Here in the best scenario, the time complexity is n log n. That is the n log n, the time complexity for merge sort and heap sort for the average and the worst case. But here for quick sort, the best scenario it's n log n, but in the worst scenario it is the n square. This is also using the divide and conquer algorithm. as in the we heard about the merge sort. So same algorithm they are using in the quick sort, but here we are using the pivot. So it will not divide from the middle, but it will choose the pivot, and it's mostly the complexity depends upon how you are choosing the pivot, and it will divide from the pivot. Yeah, this is not stable, this is unstable, similar to the selection sort. This is unstable algorithm, and it is also using the RAM only, so there is no extra memory is required. So this is also good for the small data, not good for the use data. Only merge sort is very useful for the use data. So this is all about this table. I hope it is clear. Please take a screenshot or something. This is very important. Now quickly we will look for the 15 MCQ. I hope if you solve this 15 MCQ, it is good, like you will cover complete syllabus. Okay, so let's talk about the first questions. How many passes does an insertion sort algorithm consist of? We already discussed in the above diagram. This is n minus 1. Even for the selection sort also it is n minus 1. So the right answer will be the B. Go to the next questions. Which of the following algorithm implementation is similar to that of the insertion sort? So what is doing the implementation of insertion sort? It is like if this is an array, so they will choose the first this one, and if they will compare with this data, is it greater than or less than? If it's this data is second data is less than the first data, then it will be put at the right places here. So it will come to here, and this will go to here. So in this case we will choose, for example, in the one iteration, if you choose this element, so they will find what is the right places, and they will keep at the right places this data. So similar type of algorithm we are using in the binary heap. So binary heap will be the right answer. What is the average number of inversion in an array of n distinct number? So okay, uh, how many average? So for example, there is n element. If there is n elements, then how many pairs will be there? So pair will be there, like we have to choose 2 from the n. So that is nc2, that is n into n minus 1 by 2. Now we have to find the average of this one. So it will be n into n minus 1 by 4, like 2 multiplied by 2. So this will be the right answer. What is the running time of an insertion sort algorithm if the input is pre-ordered? So we know that this is the best scenario. If already sorted, then it's the best scenario, and in the best scenario the complexity is on for the insertion sort. For the bubble sort also it's a on. Let's see this diagram. For the bubble sort also it's log n, for the insertion sort also it's a log n. What will be the number of passes to sort the element using insertion sort? So we know that insertion sort, if it's n element, the number of passes will be n minus 1. So here number of element is 1, 2, 3, 4, 5, 6. So 6 element is there. Then the answer will be 6 minus 1, that is 5. Which of the following real-time examples is based on insertion sort? Okay. Uh, if you guys have not yet subscribed, please subscribe it and share with your friends. Thank you. So this question is saying which of the following real-time examples is based on insertion sort? So I already discussed real time example for the insertion sort is arranging a playing cards. How you are arranging the playing cards in your hand. For database scenario, we are using the merge sort, arranging book on the library. I think this is selection sort. The next question is, which of the following is correct with regard to insertion sort? So insertion sort is stable and it sorts in place. Insertion sort is unstable and it sorts in place. Okay, so the answer is A. So insertion sort is stable. So whatever the arrangement will happen for after the sorting, it will be fixed, and it is sort in place. Sort in place means it's an internal. No need extra memory is not required. That's why it is sort in place. So whatever the array it is coming, they will perform on the same array. So that's why it is called the sort in place. So no extra memory required. Okay, let's talk about the question number 8. In insertion sort, the average number of comparison required to place the seventh element into the correct position. So average scenario will be for the nth element. Average number of comparison will be for the nth element is n plus 1 divided by 2. So in this case 7 plus 1 divided by 2, it is 8 by 2, that is 4. So the right answer will be the 4. Which of the following is not an exchange sort? So we discussed that the bubble sort is the exchange sort because they are going to exchange two elements from the given array. So bubble sort is the exchange sort. Quick sort is also exchange sort. Partition exchange sort is already exchange sort. Name is saying the options will be the insertion sort. What is the external sorting algorithm? Okay, so external sorting algorithm is the where the data is stored into the secondary memory. So the algorithm that uses the tape or the disk during the sort. So first is the option, what is the external sorting. The given array is 1 2 3 4 1 2 4 3. Bubble sort is used to sort the array element. How many iterations will be done to sort the array? So here we see the 4 element is there. Then I told that the outer circuit having n iterations and the inner having n minus 1. So the right answer will be 4. In the following scenario, when will you use selection sort? The input is already sorted. The large file has to be sorted. No, in the large file it will fail. The large value needs to be sorted with a small key. The small value needs to be sorted with the large key. The right answer will be C. When the large value needs to be sorted with a small key. What is the advantage of selection sort over other sorting techniques? It requires no additional storage space. That is correct because we know the complexity, space complexity for this one is O1. It's a constant time. It is scalable. No, it's not scalable. So the right answer will be the A. Okay, let's talk about the question number 14. The given array is 3, 4, 5, 2, 1. The number of iteration in bubble sort and the selection sort respectively. For the selection sort, we know that it is n minus 1. So n is here 1, 2, 3, 4, 5 elements as given. So 5 minus 1, that is 4. And for bubble sort, it will be the outer will be n. So that is 5 element is given, then the 5. So 5, so A will be the right answer. Okay, let's talk about the question number 15. That is the last questions. What is an in-place sorting algorithm? So in-place sorting algorithm is an algorithm where we generally don't need any extra memory. So it is saying that the first option is saying it needs O1 or O log n memory to create the auxiliary locations. The input is already sorted in place. It requires additional storage. It requires additional space. So no. So first is the right answer. It needs O1 or O log n memory to create the auxiliary location. So I have completed the MCQ. I think the complete session has completed. Please go and check it once again. This table is very important. I did not ask any questions about the worst case and the best case, but remember that bubble sort, selection sort and insertion sort, the average worst case complexity is n square. Bubble sort is having best scenario n and the insertion sort also having best scenario n. So I think this session is completed. If you like, please subscribe and share with your friends. Thank you very much.